Hey, welcome back to your favorite intermediate algebra course. We're going to talk about some quick graphs of linear equations in a couple of different forms today. We're going to use the slope-intercept form of a linear equation. We're going to use the standard form of a linear equation. So if you see there, a slope-intercept form is anything of the form y equals mx plus b, where m is your slope. So we got our slope here, and b is your y-intercept. So for example, if you have y equals negative 2x minus 4, then your y-intercept is negative 4. That's where it would cross the y-axis, right? And your slope is negative 2. Okay, your slope is negative 2. In other words, it goes down to right 1, if you recall from your algebra 1. And we'll do some of this down to right 1, okay? So that's your slope-intercept form. A standard form, on the other hand, is anything of this form, ax plus by equals c. So let's take, how about 2x minus 3y equals 8, for example. Okay, and a and b cannot both be 0 in this standard form. All right, let's graph some equations in this slope-intercept form. So here's your steps. Okay, probably quite a bit of verbiage here, but just write down for your step 1. First thing is we got to solve for y. Okay, so solve for y, and then we're going to solve for y. Second thing, find your y-intercept. So I put your y-intercept on your b value. Third thing is use your slope. Okay, and then finally just draw a line through the 2 points. So let's take a look here and use these steps one by one. So here we go. Y plus 1 equals 2/3 x. Step 1, solve for y because we want in this slope-intercept form. We want it in this form so that we can identify our slope and our y-intercept. Okay, so here's y plus 1 equals 2/3 x. Solve for y. So y equals 2/3 x minus 1. And you're looking at this, you're like, oh yeah, okay. My y-intercept, my b value, must be that negative 1. So that's step 2. Identify b. My b equals negative 1. That's my y-intercept. You go ahead and you put that on your xy coordinate system, your Cartesian coordinate system here. Your y-intercept, where it crosses the y-axis, at negative 1. All right. Step 3 now is identify our slope. Now we know our slope is rise over run. Okay. Rise over run. So we look up here and we say, well, what was our m here? Our m was 2/3. 2/3. Okay. You remember our rise was our vertical change. So it either goes up or down based on if that top number is positive or negative. So it goes up if it's positive, it goes down if it's negative. Well, we look at the 2 and we say, oh, this is a positive 2. So that's going to go up, right? Our vertical change over our horizontal change. Our run is our horizontal change. We go to the right if it's positive, we go to the left if it's negative, and we say, well, that 3 here is positive, so I'm going to go right 3. Okay, and this is from the y-intercept. It has a slope of 2/3. That's the steepness. So I say, okay, up 2 and right 3. 1, 2, 3. There's our point. Up 2, right 3 if you want to keep putting points on. Okay, and you draw the line. There it is. Okay, so solve for y. Identify your y-intercept, your b, put your y-intercept on there, and then use rise over run, your slope, to plot the next point there. Let's do another one. How about negative 2y plus 6 equals 8x? So number 1, let's solve for y. Solve for y here. First, get rid of that negative 2. Divide this side by negative 2 and the other side by negative 2. I say, oh yeah, this is in slope-intercept form, isn't it? So step 2, what's my y-intercept? Positive 3, right? Put that on the graph. 1, 2, 3. There it is. Crosses the y-axis right there. Number 3, what's our slope? Our rise over run. What's our slope here? Looks like it's -4. Well, it's not in a fraction. I got to write this thing as a rational number. So I put it over 1. -4 over 1, same thing, -1, of course. And I say my rise is -4, right? Remember, rise is your vertical change. So do I go up or down? I say, well, that's a negative number. I actually got to go down 4. And then my bottom number here is a positive 1. So I go to the right 1, down 4, 1, 2, 3, 4, and right 1. Right there. Down 4, right 1. Ah, totally missed those. And draw the line through those 2 points, right? And by the way, some people like to, you can go the other way. Another -4 over 1, isn't that the exact same thing as 4 over -1? So really, from the y-intercept, we could also go up 4, left 1 if we wanted to. 1, 2, 3, 4, and left 1. And you see it's still on that line, isn't it? Still on that line. Well, had I drawn the line better. So anyways, let's move on here. That was a nice review of your slope-intercept form here. Now, how about your standard form? Okay. Number 1, make sure that this thing is in standard form. Number 2, find your x-intercept. Find your x-intercept, and to find an x-intercept, you let y be 0. And then find your y-intercept, and then draw a line through the 2 points. Okay, so we're going to do a little table here to help you out with that. So let's look at this thing. Graph 2y minus 3x equals 6. Okay, so we make sure, is this in the form ax plus b, y equals c? I say, yeah, well, I mean, preferably you'd put the x first, right? So yeah, that's good enough according to our definition of a standard form there. Just gonna put that in the form. And then secondly, now we want our intercepts, okay? So to find our x-intercept, you let y be 0. And why is that? Well, if you have a line that crosses, okay, the x-axis, right? Like this one. Okay, well, what point is that? -2, 0. Let's look at another one. Let's say we have a different line. And it crosses the x-axis. What point is that at? Oh, well, that's at 4, 0. Let's say we have another one. And this crosses at -5, 0. Okay? What do you notice about all these points? In common, all of them have a y value of 0, right? That's where they're crossing the x values when their y value is 0. So to find an x-intercept, we let y be 0, okay? And then we solve for the x, and it'll give us the location of the x-intercept. To find the y-intercept, on the other hand, we let x be 0, right? We let x be 0. Look at this green one. You notice that it hits right there at 0, 5, right? Look at the blue one. It hits at 0, 2, right? So our x value is 0 for a y-intercept, okay? All right, let me erase this and let's actually graph this line here. Oops. Okay, so first of all, find the x-intercept by letting y be 0. So let's do that. So we're going over here and we're going to say our x-intercept, we let y be 0 in the equation. So we're letting y be 0. Divide by -3 both sides and we get -2. Okay, so -2 comma 0. That's our first point on the graph. -2 comma 0. There's our x-intercept. Now we find our y-intercept. Find the y-intercept. Find the y-intercept by letting x be 0. Okay, so we got 2y equals 6. Divide both sides by 2. And we got 3. So when x was 0, y ended up being 3. There's the point. Draw the line. There's our line. Negative 3x plus 2y equals 6. Negative 3x plus 2y equals 6. Okay, and you notice if we would have done it in slope-intercept form, here's negative 3x plus 2y equals 6, we'd have solved for y first, right? Let's just check it with our slope-intercept form here. 2y equals 3x plus 6. We'd have divided everything by 2. Y equals 3 halves x plus 3. We'd have put the 3 on, and then we'd have gone up 3, right 2. So let's do that. Put the 3 on. Whoops. The 3 on. Up 3, right 2. Boom. There it is, right? You draw the line. Hey, it's the same line. Or you could have gone down 3, left 2, right? Negative 3 over negative 2, same thing as 3 halves. Okay? So you notice it's the same line. Either way you do that in standard form or in slope-intercept form. Let's graph this one in standard form. Let's put this in standard form first. AX plus BY equals C. So you notice I just got to switch those around, don't I? Again. Okay. And notice, what if we just started out? Let's say it was this. We would have added the 2y, right? Get it over here first. And then we'd have 4x plus 2y equals 4. Okay. So just note that. If you ever have something on the other side that doesn't belong there, put it on the other side. All right, now we get our x and y intercepts, right? To find our x-intercept, we let y be 0. To find our y-intercept, we let the other variable x be 0. Okay, so let's do our x-intercept here. X-intercept, 4x plus 2y equals 4. Letting y be 0. X is 1. Okay, now find our y-intercept by letting x be 0. Let's divide by 2. Looks like we got 2. So we got 1, 0, 1, 0, and 0, 2. Draw that line. You only need 2 points to draw a line for these linear equations because you know they're perfectly straight. Okay. All right. Now, horizontal and vertical lines, okay? If you have the graph of y equals c, that's a horizontal line through the point 1c. If you have the graph of x equals c as a vertical line, then you know it goes through the point c comma 0. And if you're not sure, let's look at this first one, x equals 3. This might be a good way to think about this. X equals 3. You notice there's no y value. So if you're point plotting, maybe a good way to think about this, you're like, well, x is always 3. It's always 3, right? Regardless of the y value that I plug in, x is always 3. So you got 3, negative 2, you got 3, negative 1, you got 3, 0, you got 3, 1, you got 3, 2. And soon enough, you see the behavior like, oh yeah, that's vertical, right? Y equaling a constant on the other hand. So y equal negative 2. You're like, well, what would that look like? Y equals a constant. Y is always negative 2. That's the only option here that we have. And you're like, well, pick some x values this time. Can't plug those x values in. There's no x value to plug in. Y is always negative 2. But you can plot these, negative 2, negative 2, negative 1, negative 2, 0, negative 2, 1, negative 2, 2, negative 2, and so on. And soon enough you see, oh, that's perfectly horizontal. This is what y equals a constant looks like. It's horizontal at that y value of negative 2, whereas x equals a constant is vertical at an x value of 3. Okay? All right, make sure you guys bring your questions to class. We'll see you soon.